Well, hello everyone. What we have now is the last part of chapter 5. This is all we need to cover for this week, week 3. You should also be aware that this coming Monday, we are going to have your midterm exam. All homework, that's homework assignment 3 and online test 3, have to be completed by midnight Sunday, and there will not be any extensions. So it's up to you to make sure that you get that done and that you're prepared for your midterm, which is going to last you 3 hours. And that midterm is going to be on Monday, the 25th. So make sure that you're ready for it. Okay, so this one is applications, essentially. And the applications are talking about here are solving quadratic equations, or at least equations with polynomials. Now, the first kind that you're going to get are ones where the factoring has already been done for you. So it may be a minus 1, a minus 7 equals 0. Now, there's a rule that says that if you have two things multiplied together and it's equal to 0, then the conclusion you can make is either the first term, this factor, could be 0, and or this factor could be 0. And the value of a that makes that 0 is 1, and the value of a that makes that 0 is 7. And you'll be writing it down as they call it a comma-separated list. So you would write it down like that. And that particular one is an example similar to question 1. Now let's show you another one that's also factored. Let's suppose it's x plus 3, x minus 1 equal to 0. So this is actually a cubic rather than a quadratic, but it's the same basic principle. We have this factor, so x equals 0 is one of the solutions to this polynomial equation. In the second situation, you're looking for what makes x plus 3 0, and you get that. And from this one, you are looking for the factor, what makes that factor 0, what value of x, and the answer to that is 1. And so your solution will be, in numerical order, -3, 0, and 1. So there are, as you'd expect in a 3 multiplication situation, that you're going to get 3 solutions. Now, an example, same idea, but just a little bit more awkward. But the numbers aren't going to be anywhere quite as nice, would be this one. 3x plus 7 is a factor, so is 2x minus 3. So these two equal 0, and they must equal 0 for this to work. Lead us to either the first factor is equal to 0. And to solve this, I'm going to subtract 7 from both sides and then divide both sides by 3. So there's one solution to this equation. The other factor could also be 0. I'm going to add 3 to both sides, and I'm going to divide both sides by 2. And there is your 2 solutions. And what we're going to look at now is what happens if you get an equation involving a polynomial, but it's not factored. So you might get a question where you have this. Now, if you haven't seen this situation before, this, when you have something squared, take away a number typically, right? So in this case, b squared, take away 64. This is called a difference of two squares. And we are going to factor the left-hand side. And there's a very simple way to do this. When it's only two terms, squared terms subtracted. your solution has this formula. It's b plus, b take away. 64, 8, and 8. If it was b squared take away 25, it'd be plus 5 and minus 5. If it was b squared take away 9, it'd be plus 3 and negative 3. If it was b squared take away 1, it'd be b plus 1, b take away 1. Now, we have two factors, just like we have here, and from this point, it's pretty standard. You have that factor could be 0. So if you take 8 away from both sides, you get that. Or this factor could be 0. If you add 8 to both sides, you get your second. So these are the two solutions to that particular quadratic equation. Now, let's move on to a different type. This is a version of question 5. And in this case, we're going to have y squared, add 7y, take away 8 equals 0. So this is where we bring in some of the things that we've done in the past. Trinomial quadratic. Since it has a y squared, I know it's going to be y and y. Since this number is negative, I know that it's going to be a plus or a minus. And I am looking for two numbers that multiply together that give me negative 8, but when I add those two numbers, I get plus 7. So I could have negative 8 plus 1, I could have plus 1, negative 8. I could have plus 2 and negative 4, I could have negative 2 and plus 4. And I believe that's all the combinations I've got. And if you look really carefully, that's the one that if you add them together, you get plus 7. So it's plus 8 can go here, minus 1 can go there. You can now solve it. The first factor could be 0. Subtract 8 from both sides, and you've got one solution. The second factor could be 0. If you add 1 to both sides, you get that. So y equals negative 8 or y equals 1 would work. Now, you wouldn't normally do this, but you might want to do it, especially in the test. You can check your solutions. Well, let's just check one of them. I believe that if y equals negative 8, this expression will equal 0. Right? So this expression will equal 0 when y is negative 8. Let's see if that works. Negative 8 squared plus 7 lots of negative 8, take away 8. Negative 8 times itself is 64. 7 times negative 8 is negative 56. Take away 8. 64, take away 64. And yep, it works. Check. We know that we have solved this equation. And if you try 1, it also works. 1 squared is 1, plus 7 lots of 1 is 7. 1 plus 7 take away 8, it is equal to 0. And we also know from the way the math works is that these are the only two solutions. There's not like a third value of y that works and we haven't found it. There are only two, and these are the two values, and we are essentially done. Now, imagine you got a question like this. X squared, take away 6x, plus 9 equals 0. Well, we would factor it. This is positive 9, but this is negative 6. So I'm looking for two numbers. Both of them have to be negative, right? So that when you multiply them, you get plus 9. And when you add these two negative numbers together, you get negative 6. So I'm looking at negative 1 and negative 9, and negative 3 and negative 3, right? That's the only two ways I can make 9 happen with whole numbers. And that's the one, that one here, that if you add them together, you get negative 6. Now, something kind of interesting happens here. Both of these factors, the same. Both of them have the same solution, x equals 3. So when you write down your solution, and you do it in your box, you just write 3. You do not write 3 and 3. That's kind of redundant. You just need to write down x equals 3 and you've solved this equation. If you're interested, x minus 3 times x minus 3 would be abbreviated in mathematics by calling it x minus 3 squared equals 0. Now, let's move on to a much more difficult version. We have 3x squared, take away 13x, take away 10 equals 0. Now, these are the more complicated questions. 3x squared means 3x and x. Now I'm looking for numbers that multiply together to give me negative 10, and when I put them in here and FOIL it out, I need negative 13x. So if I think of all the ways to get negative 10, there is negative 1 and plus 10, there's plus 1 and negative 10. You then have to switch places, because a 1 here and a 10 there is not the same thing as a 10 here and a 1 here. So I'm now going to go plus 10 and negative 1 and negative 10 and plus 1. So just for that combination of 1 and 10, there are actually 4 different mixing ways to mix it up. Now, the other way to get 10 is 5 and 2. So plus 5 and a negative 2, a negative 5 and a plus 2. Then I'll put the positive 2 with a negative 5 and a negative 2 with a plus 5. Now that is 8 different choices. So I'm going to pick one that I know that doesn't work, and then I'll pick one that does. So let's suppose I test this one out. So it'd be a negative 10 here, and it'd be a plus 1 here. Now, if you do this calculation, then this one, and then that one, and then finally that one, you end up with negative 10x, right? Negative 10x plus 3x. And the terms 3x squared and minus 10 work. So I can kind of just do this piece, right? Which is the inside, right? And the outside. And I know that that isn't going to work because it's negative 7x. So I'm going to try again, but this time I'm going to pick the one that does work. And I'm not sure that they're plus or minus yet, so let me just figure out what I'm going to get. I'm going to get something big here, so that's going to be 5, and that guy is going to be 2, and I believe that is a solution that works. That times that guy is 3x squared. That guy times that guy is negative 15x. That guy times that guy is plus 2x, and that guy times that guy is negative 10. And can you see that these two give you exactly what you needed? So the result is that after a little bit of work, we have figured out a way to factor this particular trinomial. And the factoring that works was 3x add to x minus 5. So to solve it, we take the first factor, set it equal to 0, and solve. I'll subtract 2 from both sides, and then divide both sides by 3. Or you go for this one, you add 5 to both sides, and here are your 2 solutions. And we are finished. In WebAssign, they have x equals smaller value, which is negative 2/3. And then you have x equals 5, the larger value. So that's how they get you to put them in a particular order so that they can solve the question. Now, you may well get, here's an example of it happening, 5x squared plus 9x plus 3 equals 0. And this expression does not factor. Now, if that happens, you will write down, just looking for the word that they use. I'm pretty sure it's no, I know it's no solution, but I'm wondering if they had a term that you use when that happens. Looks like none of the questions have that issue, so I guess you don't need to worry about how you would solve it or how you would write it down. But if it doesn't work, it doesn't work, and that's fine. Now we're going to look at some questions that you could not notice that you have to do some extra work. This is the equation, but this is not the format that I need if I want to solve it. I need to subtract 5 from both sides because all quadratics have to be equal to 0 to do this factoring method. So I need to figure out how to do this one. It could be a 2y and a 2y. And then I'd look for all the combinations of -5, try them and see if any of them work. I know that that doesn't work, so let's just pretend I did all those and they didn't. The other possibility is 4y and y, right? 4y times y gets you 4y squared. So let's look at how you can get 5. Well, -5 in particular. You can only get +1 and -5, right? One has to be positive, the other has to be negative. And you can switch places. Right? Switch signs, I should say. And then you can switch places. So there are only 4 combinations to choose from. It has to be one of them if it's going to work. And I'm picking -5 here and +1 here. So that's this one here that I've picked. Let's check it out. 4y times -5 is -20. -20 plus 1 gives you -19y. I know that is the one that's going to work. So I can now solve the question. You take this factor and make it 0. You subtract 1 from both sides, and then you can divide both sides by 4. And here is one of your solutions. And this one here, you take this factor and you find out what makes it equal to 0. If you add 5 to both sides, you'll be able to find that out. And there's your second solution. And we are done. So the first group of application questions were essentially solve quadratic equations. So let's now look at some other kinds of applications. So this one is question similar to 11. And you're told that the number of possible diagonals that you can get in a shape, D, of a polygon. Now, a polygon is a shape that looks like this, right? That one's got 5 sides to it, for instance, is n take away 3 all over 2. And you're being asked to find the number of sides. So find n, which is the number of sides. So for instance, in this one here, n is 5, right? There's 1, 2, 3, 4, 5 sides. And the diagonals they're talking about is, you know, a line from here, a line from here, a line from here, a line to here. If I missed one, yeah, there's a line going down here. Right, would be 1, 2, 3, 4. There'd be, I think, how many would that be? It'd be 5, I think, in that case. But we have to find how many sides you need to have a diagonals of 65 of them. So you begin with the equation. And you make this 65. And now our job is basically to solve this equation for n. Now I'm going to use a method I use a lot. I'm going to use that as long as you do it to both sides, it's okay rule. So I'm going to multiply both sides here by 2. I'm then going to distribute this. which looks like that. And then I am going to subtract 130 from both sides. And now I will factor. Now I know 130 is a really big number. So I'm looking for two numbers, one positive and one negative, because this is negative 130. And I want to find them so that when you multiply them together, you get 130. But when you add them, you get negative 3. And so it looks to me like negative 13 and plus 10 does the job. And if you check it out, it is correct. So we can now solve it. Now n equals negative 10 here. Just do that in my head. And n equals 13 here. Right, that's my second choice. And I am going to only pick one solution. And you may think, well, what's wrong with n equals negative 10? Well, normally it would be a problem, but in this case, n represents the number of sides your polygon's got. And you can only have 2 sides or 22 sides. You can't have negative anything sides. So that means there's only one solution. And when you write it down in Weber sign, you write down 13 sides. So that was an example of a quadratic equation helping you to solve a problem. So here's question 12. And question 12, the width of a rectangle is 5 less than its length. So I'm going to go width and might draw a little picture to help me, which I'm calling x. And I've got its length. And what do we know about it? Well, the width of a rectangle is 5 less than its length. So I'm going to actually call the length x. So I'm going to call this the length. And I'm going to call this x. And since the width is 5 less than it, I'm going to call that x minus 5. So, yeah. So have I got that? Yeah, the width is 5 less than the length. Okay. Now, what else do we know? They tell us that the area of this triangle is 500 square feet. Well, I know to get the area, I would multiply the length by the width, and it should equal 500. So it's x times x minus 5 should be 500. And if I distribute, I get to here. And then if I subtract 500 from both sides, I get to here. So I'm looking for two numbers that multiply together that give me negative 500. And when I add them together, I get negative 5. I know one is positive, I know one is negative, and I'm going to go negative 25 times 20, and that one works. And this one gives you a solution that x is negative 20, and this one gives you a solution that x would be 25. And this one is not useful because you can't get negative lengths for sides of rectangles. So that means x is 25. So I can write down what the length is. The length is x, which makes it 25. And the width is 5 less than that, which is 20. So there's your length, and there's your width, and you're finished. No. I'll just start question 13, but I won't complete it. In question 13, you've got a triangle, so let's pretend that's the triangle that they're talking about. And the height of this triangle, so that's that distance there, the height, is 4 centimeters more than twice the length of the base. Right, this is the base. And the height of the triangle is 4 centimeters more than the length of the base. So if I make the base x, the height of the triangle is 4 more than twice the base, 4 more than twice x. And we are told that the area of this triangle is 48 square centimeters. Right, and if I want to get the area of a triangle, it's a half the base times the height. And the area is 48. And that's going to be 1/2 x times 4 plus 2x. And I don't like fractions, but we'll see what happens. 1/2 x times 4 gets me 2x, and 1/2 x times that gets me x squared. And I'm going to rearrange the x squared plus 2x, and I'll subtract 48 from both sides. And I am now at the quadratic equals 0 stage. X squared. Negative 48 gives me one positive and one negative, and I'm trying to find out how to get 48, and the combination that works for this particular situation is +8 and -6. And you can check it out, but that's the only one that works. So we have a possible solution that this factor should be equal to 0, which means x is -8. Or we have this one, which I'll just do in my head, which is x equals 6. And since this is to do with triangles and lengthy things, that's impossible. Negative numbers don't work. And so I can now do the height, which is 4 more than twice the base. Well, I know the base is x, which is 6. And it's 4 plus 2x. So that's 4 plus 2 lots of 6, which is 12. 12 plus 4 is 16. And there's your 2 dimensions. I actually didn't mean to go that far, but that's fine. So our last question, an application involving the height of an object after t seconds, and it's given by a rather ugly equation that looks like that. And you're being asked after how many seconds does it take for the ball to be at a height of 63 feet. Now you've got to imagine what this might look like, right? The ball goes up and the ball goes down. This is in time. And you can imagine that 63 feet might be here. So there's going to be a time when it reaches 63 feet on the way up, and then it reaches some kind of maximum height, and then it comes down, and there's going to be a second time. So we are trying to find these two guys. So we'll set up the equation. Here is the height, and it should equal 63. Now I'm going to add 16t squared to both sides. I'm going to take away 64t from both sides, and I'm going to take away 3 from both sides. And I get that. There are two ways to approach this. This is a really ugly quadratic to solve algebraically, but I'm going to try my best to do that. And what I've noticed as I scan through, that I can take out 4 as a common factor. So that leaves me with 4t squared minus 16t, take away 15 equals 0. And then I'm really looking for 4t squared. Now that could split as 4t and t, or 2t and 2t. And both of those are going to take a lot of permutations. So I'm going to see if I can figure out a combination that works. So it'll take me a few moments finding the solution to this. Oops, made a mistake. So you can bear with me just for a little bit longer. I'm going to show you essentially an easier way to do this using Desmos. But right now, basically just letting the calculator work on it for me. And it's a little bit better. And almost done. Made a mistake here. That's why it wasn't working out. That's better. Check that one. Nope, that's not right. Okay. Let's show you the solution using Desmos. I tried to do it, algebraically, and you could see by my attempts that it didn't really work well. There are so many permutations. I would be there for an extremely long time trying to find a combination of, what would it be? A combination of 60 that would work in this world, or a combination of 15 that would work in this world. So let's show you this method. So we're going to type in h equals the original, so that's negative 16t squared plus 64t plus 3. And then I'm going to type in the height is 63. And then I'm going to have to shrink this. Is this a line 63? Okay, I'll make it y equals. That just might make Desmos understand what I'm expecting. There we go. I had to put y equals, it didn't like h. Now, the scale here is horrible to read anything. So I'm going to go over here and I'm going to take it and tell it that I'm only interested in time starting at 0. And I'm only interested in, I don't know, let's say the first 10 seconds, see what that looks like. And let's click out and move over. That's a little bit better. And I'm going to make the x's 0 to 10 because evidently that didn't take. There we go. Now, if you click on that guy, there's one of the solutions. And if you click on that guy, there's your other solution. So you say, well, what does that represent? It represents t at 1.5 and t at 2.5. So the combination that would have worked, now that I can see that, is going to be 2t take away 3 and a 2t take away 5. Okay. So this ball will reach a height of 63 feet at 1.5 seconds, which is that point, and then it will, on the way back, reach a height of 63 at 2.5 seconds. So as I go back into this one here. That's the combination of this one that worked. Now, if you had to do this by hand, you would certainly be here for a long time. This one, when you solve it, ends up being 1.5, and this one, when you solve it, is 2.5. And that is us as far as this is concerned. And we're finished for everything you need to know for your midterm and for homework assignment 3 and online test 3. So let me remind you, you have a midterm exam on Monday. It is going to take 3 hours, and there are going to be 30 questions in it, and it's going to cover everything in the first 3 weeks. So you need to be aware of that. I don't want to get emails on Tuesday saying what midterm or when are we getting our midterm, because it's your job to pay attention, to look at the syllabus, to watch the emails that I'll be sending out reminding you of this, and you should be watching these videos, in which case you've just heard me tell you. This coming Monday, you have got a midterm exam. When you go into the midterm exam, the minute you click on it, you have 3 hours to finish it, and you need to make sure that you complete it in that time, and it has to be done before midnight on Monday. Everything that you've done, i.e. the videos that we've made, will disappear on Monday, so you won't be able to use this. All the web assigned questions, except for the midterm exam, will also disappear for Monday. So when you turn up on Monday to do your exam, your midterm exam, the only thing that you'll have that is of any use to you will be WebAssign and the test itself, and that's it. And when you go to Canvas, there'll be a couple of files there in a module that, like Desmos, that you can use to help you in that situation. Okay, have a nice weekend, and I hope to hear from you soon. Bye.